Hello everyone, and welcome back to the United States Military Files channel.
When wildfires grow faster than ground crews can contain them, the C-130 Hercules can be transformed from a transport aircraft into a flying fire truck. The key is the Modular Airborne Firefighting System,
Better known as MAFS. Instead of permanently rebuilding the aircraft,
crews roll a palletized tank system into the cargo hold, secure it to the floor, connect power and control lines,
and fit a nozzle through the left paratroop door. In a short time, a military airlifter becomes an emergency tanker,
able to deliver thousands of gallons of retardant over burning terrain. The second-generation unit can carry about
3,000 gallons, giving the aircraft capacity to paint a protective strip in a single pass. The loading process begins with coordination between Air Force crews, civilian fire agencies,
maintainers, and ground handlers. The aircraft is positioned. Chocked, powered, and opened at the rear ramp. Forklifts or loaders align the MAFS-2 module with the cargo floor. Loadmasters guide the unit forward inch by inch,
making sure rollers, locks, and tie-down points line up correctly. Once the module is seated, chains secure it against movement during takeoff, maneuvering, and landing. Technicians then check plumbing, compressed air, electrical connections, and the discharge system
before testing valves and controls. MAFS-2 works by using compressed air to force retardant out through the side nozzle. The crew does not simply dump liquid at random. Before launch, pilots receive a target area,
route, altitude, communication plan, and drop instructions from fire officials.
The aircraft then departs like a normal C-130, but its mission changes once it approaches smoke, ridges,
wind shifts, and other firefighting aircraft. During a retardant run, the C-130 descends
toward the drop line while maintaining speed and spacing. A lead plane may guide the crew toward the correct path.
Inside, the MAFS operator monitors the system, arms the controls, and releases the load at the planned point.
The retardant exits in a long red stream, coating vegetation ahead of the fire to slow its advance and give firefighters time to build a line.
The 2011 launch from Dyess Air Force Base to support the Deaton coal fires showed how quickly
military aircraft can join civil authorities when wildfires overwhelm local resources.
The 2018 MAFS training cycle reinforced the same lesson. Crews practiced loading, taxiing,
takeoff, pattern work, communication, and simulated drops, so that real missions would not be improvised under smoke and pressure.
MAFS is powerful because it uses aircraft already built for tough missions. The C-130
can operate from many airfields, carry heavy loads, fly low and steady, and turn around for repeated sorties.
It does not replace firefighters on the ground, but it changes the tempo of a wildfire fight.
When roads close, ridges block access, and flames run through dry brush, a Hercules fitted with MAFS
can put a defensive line where crews need it most, safely buying time for bulldozers and hand crews to protect escape routes. Before aircraft drop retardant, fire managers need to understand where the fire is moving, how hot it is, and what terrain or fuel lies ahead. That is where NASA's ER-2 research aircraft adds a different kind of power.
The ER-2 is a high-altitude research version of the U-2, adapted for science, mapping,
atmospheric sampling, and Earth observation.
Flying far above normal traffic, it can carry instruments that observe the ground in wavelengths the human eye cannot see,
including infrared signatures that separate active flame from smoke-covered ground, from far above safely.
During Southern California wildfire mapping in December 2017,
NASA used an ER-2 carrying imaging instruments to study active fires and smoke from high altitude. Instead of fighting the fire directly, the aircraft gathered data. Sensors measured visible and infrared energy, allowing researchers to identify fire intensity, burned areas, smoke behavior, surface conditions, and remaining fuel. This kind of mapping helps scientists understand
fire behavior and helps emergency teams imagine how future airborne data could support response.
The process begins with mission planning. Scientists choose the target area,
Weather windows, instrument settings, and flight lines. Pilots take the ER-2 high above the burn area,
where the aircraft follows precise tracks while sensors scan below. Data is recorded, processed,
and turned into images or maps that reveal details hidden by smoke or distance. The ER-2 proves that wildfire response is not only about water and retardant, it is also about information. A C-130 can build a line on the ground, but a research aircraft can help explain where danger is growing, which areas are hottest, and how fire transforms
the landscape beneath it. During the 2017 flights, NASA's Aviris instrument collected hundreds
of spectral channels, turning a research mission into a detailed airborne scan of heat, smoke, vegetation, and burn scars.
Helicopters bring wildfire response closer to the ground. When flames threaten remote ridges, thick forests, or communities with limited road access.
Aircraft such as the CH-47 Chinook can move firefighters, supplies, and water into places trucks cannot reach.
During the Red Bank fire, California National Guard Chinooks lifted firefighters and equipment across difficult terrain,
turning a heavy transport helicopter into a logistics bridge between fire camps and the fire line,
especially when steep terrain made road movement slow or unsafe.
Air crews check landing zones, passenger counts, weight, weather, and fuel. Once the helicopter is ready, troops or firefighters board quickly, secure themselves, and prepare for movement at the landing site. Crew members guide them out while rotors keep turning, and the aircraft lifts away for the next mission. For water drops, helicopters often use Bambi buckets, flexible containers slung beneath the aircraft. The helicopter descends over a lake, pond, or portable tank, lowers the bucket into the water, and lifts once it fills. Pilots then fly toward the fire while managing the swinging load below. At the target, they release the water over hot spots, burning slopes, or threatened structures. Helicopters also become rescue aircraft when evacuation routes disappear.
During the Creek Fire in California, National Guard crews rescued more than 200 evacuees
from dangerous mountain conditions. Pilots had to find suitable landing areas, avoid smoke and obstacles,
Load frightened civilians quickly and fly them to safety. The mission demanded calm cabin control,
fast passenger movement, and repeated trips in poor visibility. Behind every flight is a base operation.
Truck companies and support units build shelters, move supplies, establish rest areas, and prepare temporary camps for firefighters and troops. During the campfire response, military support helped create working spaces where responders could sleep, eat, receive assignments, and maintain equipment. Wildfire aviation is therefore a chain. The C-130 Hercules can quickly build a line of retardant to slow the flames.
ER-2 aircraft map the danger. Helicopters move people and water, and base camps keep responders alive.
None works alone, but together they stretch the reach of firefighters across huge, dangerous, burning landscapes, where minutes can decide whether crews hold a ridge, save a road, or lose an entire threatened community under extreme pressure. Fire becomes even more complicated when it erupts aboard a boat or ship. At sea or in port, flames can spread through tight compartments, vehicles, fuel, cargo, insulation, and ventilation pathways. Access may be limited, visibility can vanish, and steel decks can trap heat.
A small recreational vessel fire near the Farallon Islands shows the basic danger.
Large ships multiply the challenge. The USS Bonhomme Richard fire in July 2020 burned for days in San Diego and caused severe damage to the amphibious assault ship. Sailors and civilian firefighters battled smoke, heat,
and difficult access inside a massive warship. The incident reinforced why shipboard firefighting training is constant.
Teams practice hose handling, boundary cooling, breathing apparatus use, compartment entry, communications, and casualty evacuation.
Because a ship cannot always rely on outside rescue. The ship carried vehicles and had 12 decks, including an exposed upper deck.
And measured about 692 feet in length. When fire broke out, smoke and heat moved through cargo spaces and access routes.
UAS and thermal imagery helped responders observe hot areas from above, while tugs sprayed water onto the vessel from outside.
A ro-ro vessel is built to move vehicles through ramps and decks, which makes cargo handling efficient but can also create large connected spaces.
Once fire reaches vehicles, tires, plastics, fuel residues, and interior materials, conditions can deteriorate quickly.
Responders must understand deck layout, fire doors, ventilation, fixed systems, and safe entry points before sending teams inside.
Shipboard firefighting training teaches that water alone is not enough.
Crews isolate compartments, cool boundaries, maintain accountability, monitor air, and control openings so oxygen does not feed the fire.
From a MAFS-equipped C-130 crossing a smoky ridge to a helicopter lifting evacuees and firefighters.
Airborne response changes what is possible during wildfires.
Yet the shipboard fires remind us that fire is dangerous wherever it starts. On land, in the air, or inside steel cargo decks. Survival depends on preparation, coordination, and trained crews who know how to attack danger before it grows beyond control. Whether the answer is a retardant drop, an evacuation flight, a tugboat stream, or a hose team entering a smoky deck. The real invention is coordination between machines and trained people working together. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. Thank you.
Keep moving, push up the line. Watch the embers on the right.